covering the distribution, and the first distribution is the chi-square distribution, and the formula is very simple: n minus 1 s square and sigma square. Okay, so this is the formula for the chi-square distribution, where n is the sample size, s square is the sample variance, and sigma square is the population variance. Okay, so altogether we will identify all these n, sigma square and s square from the given data and try to calculate the chi-square value, and out of that chi-square will be conclude whether we are going to reject the null hypothesis or not. Okay, so there will be two type of hypothesis will be facing: null hypothesis and alternative hypothesis. Okay, and in null hypothesis we have already communicated that all the greater, less or not equal to all the greater, less or not equal to things included in the alternative, and less than, equal to, greater than, equal to or equal to, that is part of the null hypothesis. So usually we have type of hypothesis, and we need to get some evidence to reject H naught. Okay, so first of all we'll see a question, and then you will be able to know exactly what we are doing. Yes, here is the distribution is the 230. Okay, suppose that the thickness of part used in the semiconductor, it is critical dimension, okay, thickness, and that the process of manufacturing these parts is considered to be under control. Okay, if the true variation among the thickness of the parts is given by a standard deviation not greater than 0.60 thousand of an inch, to keep a check on the process, random sample of n is equal to 20 are taken periodically and is regarded to be out of control if the probability that S square will take on average greater than or equal to the observed sample values is 0.01 or less. What can one conclude about the process if the standard deviation of such periodic random sample is S is equal to 0.84? So first of all we have to write the null and alternative hypothesis. So what is the null hypothesis or alternative hypothesis? If the true variation among the thickness of the parts is given by a standard deviation not greater than 0.60. Okay, so it should be not greater than, so we will be having at least less than, not greater than mean less than 0.60. Okay, so first of all will be establishing alternative. So the variation should not be sigma should be less than 0.6. So that is the meaning of standard deviation not greater than sigma 0.60. If it is not greater than, it means should be less than. Not greater mean less than 0.60, less than. Okay. And then to keep check on the process, as n is 20 and are taken periodically and is regarded to be out of control, if the s square will take on a value greater than or equal to the observed sample value is 0.0 or less, even though sigma is 0.60. So it means that should be under control when it is less. So that is the alternative, and null should be equal to sigma greater than equal to 0.6. Okay. If we reject h naught, it means that our process is under control. If we do not reject h naught, it means our process is out of control. That is the meaning of it. So we have the chi-square, and n is n minus 1 s square over sigma square. So we have all these values here in this data. So n is equal to 20, sigma is equal to 0.60, and s is 0.84. So we have to put all these values. 20 minus 1, 0.84 over 0.60 square. So we are getting chi-square. So we just need to solve through the calculator. I think all the values have been in placed. So n minus 1 basically is 19. So what is the final answer? Chi-square .24. So chi-square, and we could consider the tolerance level is 1%. Okay, chi-square at 1% is 0.01 is 36. We are getting 37 or something. Yeah, 34. And chi-square alpha, and with 19 degrees of freedom, chi-square alpha is 0.01, and with 19 degrees of freedom is 36.19. So that is the rule. We reject h naught if chi square greater than chi alpha, or alpha is 0.01 and 19. We reject h naught if chi square is greater than this one. It means that 37.24 is greater than 36.19. So it means we reject h naught. Okay, we reject h naught. So the process is declared out of control. Of course, it is assumed here that sample may be regarded as a random sample from a normal population. So chi-square so I think let me no, I think we have tested the, we have to, yeah, sigma, because we want our alternative sigma less than. I think we have tested not in term of, it should be less than, not greater, less. The condition is less, because our alternative is with less than, it is mentioned. Okay, so it means that we reject H naught if it is true. It means that we do not reject H naught. We do not reject H naught. So let me tell you, little bit about the hypothesis testing and correspondingly, the way we form the rule. So if I'm just writing H naught, if for example you have hypothesis that mean greater than something mu naught, and you could have alternative mu less than mu naught. So one is in the form of greater and another is in the form of less. So for the greater, z should be greater than equal to z alpha. Okay, and for less, z must be less than equal to z alpha. Okay, so that is usually the principle when we are testing for the mean. Okay, so it means that according to the hypothesis, you have to form the rule of the rejection according to the null hypothesis. I think it should also be minus here because I'm just writing a rule for the average, for the mean, but this is not the question of mean, this is a question about the chi-square distribution. So that's why the rule is little bit without the minus, because we may not have a minus value in case of chi-square distribution. We do not get minus values, we have all the positive values. So that's why we have to write. Okay, so that is one of the question relating with chi-square distribution. So there is another question about the t distribution, and t distribution, first of all I'll be introducing a t distribution with you. So t distribution is used when the sample size is small and we want a type of a normal population is there. Okay, so the formula is here. The second one is t distribution, second distribution, and t distribution is x bar minus mean over s square root over n. Okay, so that is the formula. X bar is sample mean, and S is the sample standard deviation. N is the sample size and mean is the population mean. Okay, so now we will move to solve a question. So in 16 question example number 3, in 16 1 hour test run, the gasoline consumption of an engine average 16.4 gallons with standard deviation of 2.1. Test the claim. So now we're testing the claim. Claim is always goes to the null hypothesis. When you're talking about the claim, so claim will go all into the null hypothesis. Test the claim that the average gasoline consumption of this engine is 12 gallon per hour. So we have to test the claim. Okay. So whenever the claim is mentioned, it will always goes to the null hypothesis. Okay. So first of all, in this problem, example number 3, we would write null and alternative, and null is basically 16.4 gallons, average equal to 16.4 gallon, and it's not equal to 16.4. okay, so that is null and alternative is mentioned, and then the data is given. Test the claim that the average gasoline consumption is 12 and the standard deviation is 2.1 and 16.4, sorry, 12 is the basically, sorry, the average is given 12, okay, per hour, 12 gallons per hour. Okay, and the sample is given as 16.4. okay, and then S is given by 2.1 and N is 16. okay, that's it. So we got all those values and we just need to put all the values into the formula. S over square root n. 16.4 minus 12 over S is 2.1 over square root 16. What is T? 8. Yeah, 13. So that is T value. So now since we can see that it is not equal to, so now not equal to will go in both of the direction, less or greater, when not equal to is mentioned. So you have to see your T value. According to that you have to decide your test. So your T value is now positive. Okay, T value could be positive or negative. So now you have to decide your rule for rejection. Since your T value is positive, so it means you should write a rule with greater. Okay, greater than equal to T alpha. So on not only T alpha by 2, because we have two-tail test. Not equal to mean a two-tail test. This sign not equal to shows that it is a two-tail test. So whenever the two-tail test is there, then you have to have T alpha by 2. Okay, greater than. So your T value is already 8.13. So here is the rule: we reject H naught if T greater than T alpha. So T is 1.3, and what about alpha? T alpha by 2. So T alpha by 2 is something, for example, if we're considering 5%, so it should be around 1.96, something like that, or around 2. Okay, maximum. So I think it's 2.944 is 0.005, the probability getting. Yeah, so Yeah, from T table we can have it. So let's say it is T alpha by 2 is maximum value could be 3. Maximum that will go for T alpha by 2 is 3 with 1% of significance level. With 1% of significance level, it will go to maximum till 3. So it means till we reject H naught, because 3 I have considered a maximum value for T alpha by 2. Are you getting the point? For T alpha by 2 I am considering with new degree, this is a degree of freedom. So 3 I am considering the maximum value. So still our 8 is greater than 3. Okay? Alpha is, just telling you, I am considering the maximum. Even if I am considering alpha is 1%. Okay, even if I am considering alpha 1%, the maximum could be obtained is 3.
Always the spread?
No. It's depending upon the T value. Let me tell you, I have here the table. Let me show you the. So you could see here the T table. So what is your, let's consider alpha is 1%. So whenever alpha 1%, so select this column.
2.9.
Okay, this column.
2.9.
And with 15 degree, because 16 is the n is 16. So n is 15 is the degrees of freedom. So this one corresponding to 15, it should be 2.9. Okay, 2.9. So it means that the 3 I have considered is very logical value. The maximum value I am considering is 3. So still we are rejecting the H naught. Okay. Yeah, so we reject H naught. That is the T distribution. Okay. Now we are moving towards the last distribution. F distribution. So F distribution will be used to test the variance. Okay. If S1 square and S2 square are variance of independent sample of size n1 and n2 from normal population with variance sigma 1 square and sigma 2 square, then we would write an F distribution. Okay, so that is the formula of the F distribution. Sigma 2 square into S1 square, sigma 1 square into S2 square. F distribution is sigma 2 square S1 square, sigma 1 square S2 square. Okay, that is the F distribution. So here we could have also, if both of the the sigmas are equal, then of course it should be S1 square over S2 square, because if both variance are equal, then S1 square over S2 square. We are remaining with that. F distribution. So now we are covering the question number 82 from the exercise, and it is having by using the F distribution formula which is given, and in this formula we'll be using the values that is extracted out of this question, and 18 and 12, and you could see the sigma 1 square is 12 and sigma 2 square is 18. Okay, and n1 and n2 will be used later on when we'll see the table. And probability, our objective is to calculate the probability of S1 square given S2 square greater than 1.16. So in order to accomplish our the objective, so first of all we'll be calculating the F value, which is F is equal to 18 over 12 S1 square S2 square. So by using the values which have been given to us, S1 square over S2 square greater than 1.16, so that is the given, and by using now F will be changing the, try to find the value for S1 S2 square from the F whatever is given to us. Okay, so we have found 2F over 3 S1 square by S2 square. So we will be replacing those 2F by 3 in this given probability. Okay, so now we are getting everything in term of F. So F is 1.74, and if we look into the F table, so we obtained 5% is the probability. Okay, so ultimately in the 5% for the F is given, and that is our main concern of calculating the probability, which is 0.05 for F value. Okay, so that is the end of the question. So you already seen that, it's fine, it is just for the recording purpose.